What are the essential skills and tools for quantum computing beginners? Entering the field of quantum computing can be both exciting and challenging, given its interdisciplinary nature that spans physics, computer science, and mathematics. For beginners, acquiring a foundational set of skills and tools is crucial for understanding and working with quantum computers. Here's a list of essential skills and tools that can help beginners navigate the complexities of quantum computing. 1. Basic math and physics. Quantum computing relies on some fundamental concepts from mathematics and physics, such as linear algebra, complex numbers, probability, and quantum mechanics. You don't need to be an expert in these subjects, but you should have a solid grasp of the basics, such as matrix operations, vector spaces, eigenvalues, and superposition. You can find many online resources and courses that can help you refresh or improve your math and physics skills for quantum computing. To engage effectively with quantum computing, it's essential to immerse oneself in linear algebra and grapple with counterintuitive mathematical concepts. However, for beginners, I advocate a strategy of conceptual reverse engineering. This involves first becoming proficient with Python quantum computing software development kits, SDKs. Engage actively with these tools. Experiment, execute tests, and follow tutorials. This hands-on approach will gradually lead you to a deeper understanding, enabling you to unravel the reasons behind various phenomena in quantum computing. It's a journey that balances practical skills with theoretical insights, providing a solid foundation for mastering this complex and fascinating field. 2. Programming languages and frameworks. To implement and run quantum algorithms, you must use a programming language and a framework that can interact with quantum hardware or simulators. Several options are available, such as Qiskit, Cirq, Qbu, and PyQuil, each with its syntax, features, and advantages. You should choose a language and a framework that suits your level of experience, your goals, and your preferences. You should also familiarize yourself with the basic elements of quantum programming, such as qubits, gates, circuits, and measurements. 3. Quantum information and entanglement. One of the most distinctive and powerful aspects of quantum computing is the ability to manipulate and exploit quantum information and entanglement. Quantum information is the information encoded in the state of a qubit, which can be in a superposition of two classical values, 0 and 1. Entanglement is a phenomenon that links two or more qubits, such that their states cannot be described independently, even if they are far apart. Quantum information and entanglement enable quantum algorithms to perform tasks that are impossible or inefficient for classical computers, such as factoring large numbers, searching databases, and simulating quantum systems. 4. Quantum algorithms and applications. To understand and appreciate the potential of quantum computing, you need to learn some of the most important and famous quantum algorithms and applications. These include Shor's algorithm for factoring, Grover's algorithm for searching, quantum key distribution for secure communication, and quantum error correction for robust computation. You should also explore some of the current and future areas where quantum computing can have a significant impact, such as cryptography, machine learning, chemistry, and physics. 5. Quantum hardware and simulators. Quantum computing is not only a theoretical field, but also a practical one that requires physical devices and systems to implement and execute quantum algorithms. Quantum hardware is the term used to describe the various types of quantum computers that use different technologies and architectures to manipulate qubits, such as superconducting circuits, trapped ions, photonics, and spin qubits. Quantum hardware is still in its early stages of development and faces many challenges such as scalability, noise, and decoherence. Quantum simulators are software tools that can emulate the behavior of quantum hardware on classical computers using various methods and techniques. Quantum simulators are useful for testing, debugging, and optimizing quantum algorithms, as well as for studying quantum phenomena. 6. Online platforms and resources. One of the best ways to learn and practice quantum computing as a beginner is to use online platforms and resources that offer interactive tutorials, exercises, courses, and challenges. Some of the most popular and useful ones are IBM Quantum Experience, Microsoft Quantum Development Kit, Google Quantum Playground, and Qiskit textbook. These platforms and resources can help you access quantum hardware or simulators, learn quantum programming languages and frameworks, implement and run quantum algorithms and applications, and join a community of quantum enthusiasts and experts.